All right, I thought I'd record a few hints on how to draw out and solve the pulley drawing. So you've been given a drawing of a two-grooved pulley with a hole for a shaft in the center and a keyway that would look like this, and these are the dimensions you want to have when the keyway is completed. This drawing needs two views. You want to be able to see the pulley from the side that would show the roundness of the pulley, and then we're going to see a side view to the right of it that will show the pulley in what's called half section. I did ask that you take a look at your reference material for this that went along with the lecture content, and it was all about sections. So I'm just going to pull up that content right now. So in mod 12, you had under lecture materials drawing 12 notes that just explains what a section view is. So a section view is essentially, you imagine you're cutting the object in half. Usually, if it's a symmetrical object like this one, you're cutting it in half to show the features. Instead of showing them as hidden line format, you can see them in as object lines. The areas that you're actually slicing through material, you have to fill in with a hatch pattern. And things that would normally be object lines that we would see from the outside become hidden lines that we see beyond the other side of the section plane line. And so this view is an example of a full section because we've cut the object in half. We're looking at it and seeing the holes in section here and here, and then the shaft in the middle in section. Houses are the same way. If you do any kind of architectural print reading or architectural projects, if we cut a house right down the middle this way, it's called a longitudinal section. If we cut the house in the cross section direction, it's a cross section, and it shows how is this house being put together? What are the different materials and construction materials that are being used in the house? And this is more of like a working section of a house. We'll use hatch patterns in AutoCAD to convey material and also to just change the pattern between things that are different objects. So for instance, in this example here, if we were able to zoom in a little bit closer. Let me see here. Can I zoom closer? There it is. The hatch pattern we're seeing inside the wall is a construction hatch pattern for concrete. And the pattern we're seeing here is the pattern we use for representing backfill or clean fill that we put back up against the wall once you've dug out this hole. And then this hatch pattern that we're seeing out here is an example for, or the pattern we use for earth hatch pattern, undisturbed earth. And there's other patterns that we're seeing here that are representing materials like insulation, and then the cross section that we see in the end view of a piece of lumber is another example of kind of using a pattern to indicate that we're seeing something in section. So those patterns can be found in AutoCAD. There are ANSI patterns, there are architectural patterns. So you have the other predefined or architectural patterns. When you see AR in front of it, it stands for architecture, and those patterns have already been sized appropriately for larger architectural drawings. So we're going to be using the ANSI 31 pattern for this pulley because this is the standard pattern, or it's also considered iron. So the part or pulley is made out of iron. I think if we look at the pulley itself, let's find out. I think it's made out of iron. Yeah, right here, malleable iron, and you can see that standard hatch pattern is being shown here. So we have pretty much everything we need now and we understand a little bit what is a section. So let's see what those views would look like. So I'm going to go to AutoCAD, and I've just got the PDF inserted in here as reference. And I'm going to start off drawing the front view, which will be on the left side of the page. So the front view should, and this is an imperial drawing, by the way. And I'm just going to do a save as and save it into my folders before I get started so I can hit the save button every now and again. And we'll call it my initials, Module 12. So the first thing I'd want to do is start the circle command to generate the concentric circles that we'd see by looking at the pulley from the front view in this direction. So the first size circle that we have here is, all the dimensions can be seen here. The biggest circle, or the circle that's defining the diameter of the entire pulley, is 6 inches. The dimension to the inside edge here is 4, and then the width of the hub, we'd call it, is 2. So I'm going to do a diameter of 6, do another circle inside of that with a diameter of 4, and another circle inside that one with a diameter of 2. So that's the general object lines that we'd see from that front or primary view. Now we have to dig a little deeper to find out what size is this circle on the inside, and it's got a diameter of 1.127, so it's going to 3 decimal places. We have to pay attention to that it's going to 3 decimal places, and make sure that when we place the dimension, that particular dimension goes to 3 decimal places, as we see here. So I'm going to do the circle command again from the center with a diameter of 1.127. And so there's our center hub. So I wanted to explain how to draw this correctly. You've been given 1.238 as a dimension from the top of the key to the quadrant at the bottom. So I'm going to draw a line from the quadrant up 1.238. Whoops, wrong quadrant. Do it again. Line from here, this quadrant, 1.238. And then create a line as a construction line for now that just kind of goes across. From that line that I drew, I know that's the correct height. So this is representing the top of the keyway. I want to offset that on either side, 0.25, half of 0.25, or 0.125. So offset 0.125 on either side of the key. That's creating the key itself, so we can delete that construction line. And I want to trim using all of these edges as trimming edges, and that creates the proper shape for the keyway in the middle. And it looks like I have some extra lines down here I've just got to delete. So now we've got the dimensions. This key and the shaft rather and keyway are laid out according to the dimensions shown here. Now there's some hidden line features that are going to show up in this view, but I can't really do that without building the right side view first. So I'm going to start off by drawing a construction line using X line. I'm going to create a vertical line rather that goes through the quadrant of this circle, and then just hit escape. So I've made sure it's a vertical line and it's continuous. I'm doing that so that I can set the view distance between the two views to the offset of 2 inches. And then I'll offset again the width of the right side view. Now I can put in my construction lines from the quadrant of the pulley that I'm seeing from the front view. And I know my view will be contained within that rectangle I've just drawn. So this rectangle should be 6 inches tall and 2 inches wide. That includes the overall dimensions from that perspective. I'm also going to put a construction line. Actually, let's put a center line here. This is my first kind of tip to give you. I don't think I've set up my dimension style, so we'll do that really quickly. And this is going to be 2 decimal places to begin with, but only certain dimensions, or we're going to have to override that and make them 3 decimal places using properties to do that. And I want to suppress the leading 0 because this is a imperial drawing. So I just need to make 2 new child variations, one for radius. And I think you've seen this enough times to know why we're doing what we're doing, to get those dimensions to come out right, and one for diameter. All right, so now we're ready to go. We have everything that we need. And the reason I wanted to make that dimension style available is to place the center marks. So now I'm going to place a center mark on the large circle there, so it extends through the whole thing. And then I want, actually want to load the line types for the center layer. And we'll load the line types for the hidden layer as well. And those are the only 2 line types we're going to have in this drawing. So we should be all set with that. Now I want to have here as a reference, I'll start the line maybe 1/4 of an inch away. So then the other side of the line should be 2.5. So it extends another 1/4 of an inch on this side. So it's important to put this line in here because from this center line down, you're going to be seeing the pulley from the outside. So you're going to be seeing all these outside lines here. From the center line up, you're going to be seeing this shape here, the pulley in section. Okay, so we need to be able to see the section information up here in this top view. So we're going to want to use our construction lines to project where all of those hidden line features. Normally, if we were looking at this in a, we call it there, in a typical exterior view, these would all be hidden line features that we would see. But they're going to become object line features in this example. So this shows where the top of that hub is, and this shows where the top of the key is, and that shows where the end point here that we see at the edge of that arc would end up landing by projection. So now I've got to build the shape here. And let's go back to the dimensions that are being shown. We have 0.25 inches that we want to offset from either side of the pulley on that right side view. And then we have 0.62 inches between where this V is being created. And then down here it shows us that that V is at a 40-degree angle. The trouble with this being shown at just a 40-degree angle here is it has to be interpreted from either a 0 or 90-degree angle position for you to really know where to put those lines. So I want you to imagine we can take these 2 lines that are at a 40-degree angle and have them continue until they reach their center, and we draw a line in the center of that angle bisecting it. That would end up being in this view anyway, a vertical line that we could call a 90-degree angle if we did that. So from that vertical line that's really bisecting the angle that we have, that's 40 degrees, if we think about that, that means that the distance from the 90-degree line that's bisecting that angle to this line would be half of 40 or 20 degrees. And then from the other side would be another 20 degrees. So if we take our dimensions by, first of all, creating the pattern that's indicated by offsetting. We don't care what that dimension ends up being, that's a resulting dimension. This has to be 0.25 and this has to be 0.62, and we're doing the same thing from the other direction. Right here, these 2 points that we found are where the ends of those angled lines are going to be that have an angle of 40 degrees. So if I were to draw a line that is the midpoint between these 2 intersections straight up, that's at a 90-degree angle. The lines that we have here should be, and I'm just going to pass this right through here. So the lines that we have here should be at a 20-degree angle. So if I know where the depth of this V is here, then I can figure out where to draw the line from, and draw it at a 20-degree angle from that edge that we create. So how do I know the depth of this V? I look here and see it's also 0.62. So the depth of the pulley V here is 0.62, and I've got an angle of 40 degrees. So from here, I'm going to put in an offset of 0.62. And now I have a line I can draw. If I draw it from here, I'm just going to start at the center where the line crosses this one. I want to draw it at a 20-degree angle, and I'm not getting a 20-degree angle, so I need to set my tracking to 10-degree increments maybe. And when I look to see 20-degree angle from 90, this is 90, 20 degrees in that direction, which would be in a negative direction, would be 70 degrees. And I start from the other end and do the same thing. 20 degrees from 90 would be 110. So this is the correct angles, but the lines aren't going to the correct location. So I have to take the endpoints of those lines, because I know they're at the correct angles right now, and I could put them down here and move the other one and put it down here where I know that angle begins. And then the resulting width of the bottom of this V is where those lines cross this line that has the depth of 0.62. So if I trim to that line and then trim to the edge of the V pattern that I have here, that's the shape we're looking at right there. And there's that V. Okay, now once you've solved it in one location, then you can pick it up and copy it at another. So let me show you another approach. That was a lot of extra steps, but I wanted to make sure you understood where we got the angles from. So this time I'm going to get rid of that line. And what I do know is that is a 40-degree angle. And if I were to put that 90-degree line right where the end of the angle line begins at the top of the pulley, that's another way that I can figure out what angle that should be. So this is going down at a 270-degree angle. What would 20 degrees from 270 be? It would be, I got to turn on my object snaps again to 10-degree angles here, or my polar tracking. It would be 270 plus 10 would be 280, plus another 10 would be 290. And in this direction, I know where to stop the line. So I start the line from the other direction. This is 270, but I'm putting my angle 270 minus 20 degrees would be 250. And that's another way to look at it, because we know the location or the start point of the angle at the top. We know this should be 40 degrees when it's done. So that means we know that from 270 degrees, which this line is going down 270, I can just calculate 20 degrees from that line in this direction and this direction. So then again, if we trim everything, and we have the pulley feature showing up properly in that view. This line and this angle is repeated over here on this side of the pulley as well. And then what you can do is extend that line again down to the line that's representing where the edge of the pulley is, that we can see it from the outside. And then we want to trim that edge. So let's just mirror that over to the other side, because that has everything that we need. We mirror that over to the other side using any midpoint that you can find on the drawing. And I'm going to trim the line work. Yeah, that's right. We trim the line work from here to the center hub there, so we can more clearly see the shape of our double V pulley. All right, so let's erase these construction lines. All right, so that's the top edge of the pulley. That's what it looks like at the top. And all I've got to do now to continue this section view is to draw a line from the midpoint, half of the thickness of this center piece here, which is 0.38. So let's go over 0.19, offset 0.38. Trim between those two lines. And that is the section view of the pulley, okay? So on this half of the drawing, and by the way, you would need, these lines actually need to be put back in as object lines here because we would see them beyond. And we'd also see some object lines here for the edge of that pulley. The inside edge of that pulley would continue and show up as a object line beyond. But from here down, we're going to see all the lines that would be created as exterior object lines from these objects. So I'm going to switch to the, I'm also going to mirror this V pattern to the other side of the drawing. From the center line. And if I trim between those two, that's what we'd see down below. So using the object layer, let's go ahead and make these lines and these lines and these lines, also these lines here that are defining the edge of the object. Those are all going to be object lines. Set the line weight. There we go. Okay, so from here down, I'm going to see object lines that show the inside edge of this grooved pulley plus the outside edges of these grooved pulleys, this grooved pulley, all the way up to the center line. So we're seeing then essentially the outside view of the pulley from that center line down and the inside view of the pulley from that center line up. And I'm going to stop there because the rest of this you just need to look at the dimensions and pay attention to where we have fillets. So a fillet is where there's a little rounded edge. So you can see there's fillets here and here. So I'll just give you an example of what I mean there. And the fillets are a radius of 0.12. So we would have a fillet with a radius of 0.12. Whoops. Fillet radius 0.12. Here and here and here. You can see all of this information by paying attention to that PDF. And don't forget to put that line back in there by just extending it back up, because we do see that as an edge beyond. So that's what that top shape should look like. And then this portion in here should be hidden, hatched rather. So you should create a new layer and give it a, a color that you'd like to use for your hatch patterns, and make sure it's set to a default 25 millimeter line weight so it's thin. And you'd use the hatch command. Make sure that you pick ANSI 31 and use the select or pick points tool rather to pick the area inside of the pulley, and now we actually see that half section. So the last bit to this is to make sure you're showing your hidden lines in this view where the depth of the pulley would be. And you can use this view to project that. And then you're going to add all of your dimensions. Now I know the dimensions over here are being shown as linear dimensions, but there's no reason to do that on this multi-view drawing. I want to remind you how easy it is just to put those dimensions, and making sure they're between views. You can put those dimensions right out here. And then the dimensions for the keyway itself, it's okay to put those on the part like this. There's actually room in the pulley to do that. those dimensions right there. These two need to be set to 3 decimal places, remember? So you're going to go into Properties and set that to the 3 decimal places in precision rather than 2 decimal places. And then those numbers that we originally saw on the example sheet here will appear. And then pay attention to, how the dimensions are being placed here for our linear dimensions to identify those start points for those angles, and then the other dimensions, the angle dimension and the depth of the pulley groove here can be placed on that view. But you're going to have to place those and use both the top and bottom sides of the view wisely to figure out how to do that. So I think this grouping of dimensions here could certainly be fine up here, and then putting both the 40 degree, putting the 40 degree down here is fine. But I think I'd probably put that 0.62 dimension here, because you're dimensioning to an actual feature that's related to the ones that you're adding to that top view. This dimension plus all of the dimensions that you are going to add up here give you all the information you need to create that double V at the top of the pulley. And then you can add a note similar to this one, that all rounds and fillets are 0.12, and then you've pretty much got the drawing completed. So go into your layout, set it up on a B-size sheet of paper at a scale of 1 to 1, and you're ready to go. So I know that probably was a little bit more than just some hints, but I think we maybe needed a little bit more guidance on this, since it was a newer concept with the section views and what exactly is a half section. So I hope that helps.